next up, from Washington State in the United States, Michael Glaros. Michael, welcome to South Africa. Welcome to the conference. And Michael is with the engineering team of Microsoft Azure Cloud, and he works around the blockchain architecture. Welcome to South Africa.
Good morning, everybody.
Click right to move on. Okay.
All right. Well, I know probably when you think of Microsoft, the last thing you think of is scrappy, agile, innovative. You know, we certainly have this enduring reputation of incumbency and closed source and all these things. But our CEO, Satya Nadella, is very big on culture change. And he does these things in very little ways, but they're very meaningful to us in the engineering community that work in home office. And one of those things he does is he has these talks of different speakers that come in maybe once a month from all different fields and industries and so forth. And we had the real pleasure of having Trevor Noah, Johannesburg Zone, at our campus about maybe a month or two ago. And Trevor, he was so dynamic, he was so engaging. He was talking about, and he's a technologist too. He talked about his days as a teenager hacking computers together. He was a DJ, and he built this Windows 95 computer. He put his whole music library on it. And he was like the first DJ. He would get all these gigs because in Johannesburg, he was the first DJ to bring a computer to the gig. And instead of all these other DJs having crates of records they had to lug around and only play for like 1 or 2 hours, Trevor could play for like all night long. So the parties loved him. He could keep the parties going because he had all his tunes loaded up on his hard drive on his Windows 95 computer. Well, one night, this party was going, and then the police showed up. And that was the cue for the party to end. Is whenever the police showed up, that was a sign that, okay, party's winding down, let's end it. Well, the police surrounded Trevor. They told him to shut off his system. And being Windows 95, it was very slow on the shutdown process. So he's shutting down. He's waiting for the computer to close out. The police are getting very animated, very frustrated. They draw their guns. They order him to shut it down. The party's still going. Everybody's kind of in a frenzied state. Trevor's panicking, and finally the police shoots the monitor. The police thinks that he's going to end the computer. He shoots the monitor. Of course, the policeman, not very technical, thinking the monitor is the computer. So Trevor thinking, okay, I at least dodged a bullet. You know, he shot the monitor, but unfortunately it fried the system, including his hard drive with all of his music library on it. So now he's stuck. And I'm listening to this thinking, man, that's why you need cloud computing, right? So if he had that backup, he wouldn't have lost his library. He would have had it in the cloud. But all kidding aside, what we're really trying to do at Microsoft is really foster this innovative approach and this agile approach so that folks can get started. Because as an engineer, when I joined the blockchain as a service team, I found it incredibly challenging to take my Ethereum client and get it built out and get it networked and just get to the point where I could even think about developing a smart contract, let alone a distributed app, let alone something that's kind of enterprise scale. And so really what we're trying to talk about and what the talk is today is to really kind of walk through and position that actually the combination of blockchain technology, given the network effects, given the idea of decentralized participants coming together in this platform, is a perfect marriage with cloud technology. Now, of course, it would be great if you chose our cloud technology, but I think at the end it really doesn't matter. I think the main takeaway here from this talk is really thinking about this idea that these technologies really shouldn't be viewed in a vacuum. It shouldn't just be, I'm focused on blockchain, I'm focused on smart contract development or cryptocurrency, or I'm focused on cloud, or I'm focused on machine learning. It should really be kind of the combination of these, just as we had, say, in the early 2000s when we really started thinking about distributed applications over frameworks like EJB, J2EE, so on and so forth, that radically changed the landscape then. I think we're seeing now the right mix of technologies that can do the same. So for us in the engineering team, it really begins with talking to customers and really understanding use cases and really understanding if a blockchain is even required. Because as some of the speakers, we've heard, previously, if it's just a database, if it's something that can be accomplished with standard digital transformation, probably not that interesting. And why would you want to go through the overhead and the expense of cryptographically signing all your transactions if you're effectively just going to use a database and a traditional application stack? So the first thing we look at is, do multiple parties interact with the data potentially simultaneously? Do you have these updates taking place so that, if you had an alternative, it would be a batch environment, and that would introduce a lot of latency into the process where perhaps you need this peer-to-peer networked effect of real-time updates to actually advance the business process and the transaction? is requirements for verification rather high. So for instance, if you think about the signing process, understanding the counterparties, understanding the lineage of the transactions, and having a non-repudiated way of linking transactions together, that's all really high. And then of course, disintermediation. So real quick, I'm going to have a couple of examples I'm going to walk you through today. I want to tease one first. So beyond just being Microsoft, the tech company, I really want you to think about today Microsoft as the business. So we have, we're a large multinational business. We have a fairly substantial corporate treasury operation. And this treasury operation has many of the same functions as, several other multinationals where we have to, buy and sell around the world. We have to move cash around. We have lots of foreign exchange. We have exposures that we're constantly trying to hedge against. And of course, being a publicly traded company means we really have to disclose to our investors, what our position is, quarterly. We have to file for earnings, all of this. Well, this becomes very difficult when you've got all these different, transactions coming and going throughout the system. And so we really said, for those use cases in Treasury where we know we have 4 properties, we want to really investigate the use of a ledger. And those 4 properties are transactional security from the authentication and verification perspective, the sharing, because again, we have this network of interactions between our customers, our field sales force, our local subsidiaries, our banks, and our supply chain partners. The distribution not only of the data, but also in certain cases, the business logic. Because as you deal with these different counterparties, you may need to have business rules that are very close to the counterparty that you're engaging with to really expedite the transaction. And then finally, an authoritative view. Because as I mentioned, if we're getting into a position where we need to release our earnings statements, we better make sure that we have an authoritative view of all those interactions. So again, this is from a treasury perspective, looking at us as our own needs. I mean, this may be very different depending on your scenario, your use case, your industry. But for us, we're really looking at trying to eliminate lots of unnecessary intermediation and counterparty where possible, reduction in fraud, and really, ultimately, the biggest benefit for us is increased transactional velocity with greater 360-degree awareness. So as we get this bigger and broader network effect from all these counterparties, we really want to look, it's a crazy thing to think about the size of Microsoft. We don't really understand our credit exposures. We have lots of commercial transactions taking place where people are buying from us on credit. And a lot of times, we don't necessarily understand how much credit has been lent out. So that transparency and that visibility for us and thinking about ways in which a ledger may or may not improve that become really interesting. So thinking about the use cases that we're looking at. So my role in engineering is really to try and get out and talk to customers and really understand what's a fit, what might be a good use case, what might be a good scenario. And so this is what's kind of come across my desk and what we're trying to sort through. And so we're a very lean and very kind of agile team working blockchain at the moment from a product perspective. So we may not get to all of these, and it's a constant rewiring and reprioritization that takes place depending on the complexity, the customer need, the opportunity, so on and so forth. But what I find interesting here is certainly the financial services and industry space dominates that first column, as you might expect. But we're also hearing more and more about other non-financial services scenarios. So for instance, consider food production and provenience and fair trade and recall management. That seems very compelling because if I've got grain sitting in a silo at a port in Port of Seattle and I don't know how long that grain's been sitting there, that could have significant implications for the production company, the food distribution company, the buyer, so on and so forth. Media and digital rights management, so copyright. The whole era of iTunes and Spotify and digital distribution and consumption of media has forever changed the way in which artists and creatives are compensated for the production of their work. And so if you think about the copyright and the ability to make copyright and royalty payments much more fluid and much more transparent, there's some real opportunity there. So here's one that we've been very involved with. The company is called Webjet, very large travel services company out of Australia, focused primarily in Australia, Southeast Asia. And they came to us with a very interesting business problem. So the problem they were trying to solve is they've got this very complex supply chain that they deal with from a hotel and a travel management perspective. So as a guest, I come to my Webjet portal. I find a property I'm interested in, enter my dates, and I get a quote for a room. Seems pretty straightforward. Well, the problem is they're dealing with a whole series of different partners depending on the property in question. It might be the hotel directly, might be a management company, might be a resort company. So you've got all these different properties that have room inventory that they're publishing to the WebJet portal. Now, what frequently happens is there'll be some type of collision between the availability of the room at the time it was quoted and then what's actually there when the customer shows up. So now you've got these discrepancies that take place, and every month there's this very antagonistic conversation that takes place between all these parties where everybody logged, how many times did the room be oversold? How many times was the rate, misquoted? All of these things lead to, there's like SLA penalties that are associated with so many rooms oversold at such and such rate. So what we did instead is we said, well, why not consider a blockchain ledger based on Ethereum using smart contracts to create an exception log. So every time a room is oversold, log it to the ledger. Every time a room is actually booked at a different rate that the customer was expecting to pay based on their WebJet interaction, log it to the ledger. So now what you have in real time is this exception log, and each of these supply chain counterparties gets access to that so they can start to troubleshoot. Now you've got more relationship, more conversation, because the hotels, WebJet, their partners, they can all talk in real time and say, hey, why did you sell that room? That room was reserved because we knew we had a conference. Oh, we didn't have this visibility. So just in the 3 months that we've had this application live, we've seen a transformative effect on the business relationship between these counterparties. So no longer is everybody showing up at the end of the month with their nasty Excel spreadsheet that says, here's where you've screwed us out of this much money, and we're going to have this very aggressive dialogue. Now it's more about cooperating in real time to making sure that the guests have the best experience, the right rooms are available, all the partners get the proper compensation, and so forth. And in fact, now we're going to let this trial for several more months, but the idea is that maybe we look at actually putting smart contracts in front of the reservation system, so at real time, at the time the reservation's made, you could perhaps suggest an alternative if the room is overbooked or if there's potential for a discrepancy in price. So another one, as I mentioned, so I work very closely with our treasury department. And first I have to talk to you about, to set this up, there's a dramatic change, apart from the culture change we talked about earlier, there's a dramatic change in Microsoft's business model. So historically we had Windows licenses, you buy your CD or your DVD, you get your license key, or you buy all these products and so on and so forth. And it was this kind of tangible, very atomic transaction. You pay your 300, 400 Rand or whatever, and you get your software, and it's all very kind of transactional based. Well, now with our business focus on cloud computing, so things like Microsoft Azure and Office 365, it's a subscription model. And not only is it a subscription model, but more often than not, the customer doesn't necessarily know how much they're going to use, because maybe they're in the process of transforming their current application landscape into the cloud. And so they need some time to figure out what's the consumption model going to look like. How many virtual machines am I going to use? Am I going to stick with a single server running an instance of a SQL database, or am I going to use SQL as a service? Am I going to use NoSQL? Am I going to use Hadoop? What am I going to use? And all of those things have different sort of pay-as-you-go implications. So what we like to do from a corporate perspective is say, you know what, customer, the best thing to do is actually buy on credit. So let's give you a tenor of 12 months, figure out kind of a max amount that's appropriate given your business model, and then we'll activate your subscription. And as long as you're paying on a regular monthly basis for the consumption that you use, life is good. So it's great. The problem is we're still using 20th century methods to actually process these transactions. So to get that credit set up, one, we really have to know the customer. So if it's a brand new customer, it's a huge administrative burden for us because we have to get their details, we have to get their bank details, we have to make sure everything's routed correctly. Then the customer has to think about, if it's multiple subsidiaries at the customer that's actually providing this information, they have to sort all that information. It comes back to us in a fax or an email. What's really laughable is, so the Microsoft campus where I work, there's well over 100 buildings, and we get these letters of credit back to us addressed one Microsoft way. So now you've got this letter of credit bouncing around the local mail system, and meanwhile our treasury is trying to figure out, can we provision these people or not onto the cloud subscription? So it's a real headache, and it's a real nightmare. It's a poor customer experience because the customer wants to provision their cloud subscription. They're stuck. They're waiting for us to activate it. It's a nightmare for us from a treasury perspective because we're waiting for all these details and the information to get sorted so we can activate the letter of credit. And so it just really makes for a bad experience all the way around. Now, you would think, well, hang on a second. You're Microsoft. You've got all this technology. Why not digitize it? And we certainly could. The problem is, in this particular scenario, one digitization is not enough because you have all these multiple counterparties. So frequently what happens when we activate these letters of credit, we ask the customer for their bank details. They also have to have, then we have our bank details because a lot of times, especially if it's in a high-risk market or a high-risk industry, we want our bankers to provide risk assurance and risk management on the credit decision that we make. And so each of these counterparties would have to agree to a common data model. They would have to have some kind of site-to-site VPN connection to do reconciliation. They would have to have a common application landscape. And then, oh, by the way, who's going to administer the whole package? What happens if there's versioning or updates to source code or business rule or business logic changes? Getting all those counterparties to agree, and that's just for 4 counterparties. What happens when you start onboarding, other counterparties as well? So for us, again, this is where we thought, hang on, the ledger might make a lot of sense. So we created kind of a pre-production application. This is sort of what it looks like. Imagine you have our salespeople in the field. They agree to a deal with the customer. That then sends a note to our treasury department to begin to set up the letter of credit instrument. The applicant then, they receive a ping. They then fill in those details, and that initiates a state change that then sends an alert to the customer's bank to then vouch whether or not the customer is actually good for that letter of credit, for that amount, for that tenor. That update and information is supplied. It goes to our bankers, who then as well look at the same view and then are able to process. And then finally, it goes to our corporate as a ledger. Now, not terribly interesting by itself. I mean, it's a pretty standard workflow application. But where it really gets compelling is when we overlay it on top of the existing process, right? So the setup process, what you're looking at here is the actual screen from the setup process. That one piece, that one step, just took out 2 steps in the manual world. It also gives us the ability to take on the smart contract that has the terms, basically 80% of the standard terms are now already activated and embedded in the smart contract coming from the ledger. And so that provides the customer with the view, right, here's the term sheet we agreed to, here's the amount, go get your bank details. Again, as soon as they provide those bank details, it's going to the bank. Now, their bank has access to it, they're able to endorse it, our bank's able to endorse it, and the net effect of all this is our credit management ledger. So now we're able to see by customer, by denomination, the exposures, the amount. The next thing we're thinking about is how do we put analytics and more intelligence around this for better analytic purposes. But it really sets us up for a much better, much cleaner experience with respect to understanding our credit exposures, understanding how capital moves through our system, and then ultimately getting the customer their subscription and activated much faster. So then let's talk a little bit about the tech, because for us at Microsoft, it's about the nuts and bolts and getting it started. So as we've done the blockchain work, we've seen 3 major categories that folks really need to get this technology into production. One is from a hosting perspective, because again, you can't have these individual ledger nodes just in a vacuum. They have to actually live somewhere. You've got to put a ledger somewhere, and you've got a lot of choices. You either put it in your data center, or you come up with a networked effect where you have point-to-point connections with all the different counterparties you're interacting with, or like what we're hoping out here is you put it in a cloud. You have the ledger infrastructure itself. So again, we had that very dire experience from early days of trying to compile the ledger, making sure you have the right grunt packages and Node.js packages, and is my Web3 API, so, all of that prerequisite software has got to be built, packaged, and compiled. And then finally, you have the actual logic and the middleware and the smart contracts itself, where that's really what you're trying to get to improving your use cases is, can I put my logic, does my business logic make sense as a blockchain-enabled application taking advantage of these smart contracts? But what do I do if I need to get external reference data and so forth? So from a hosting perspective, just bit of a commercial with Azure, so bear with me. Got to do this. We have a very large footprint globally. So from a hosting perspective, What's very compelling when you set up your blockchain environment, using the cloud, is you've got lots of options of where you can actually host your ledger, and that also gives you flexibility from a disaster recovery perspective. So you can imagine where you can provision multiple ledger nodes across any of these data centers around the world. Excuse me. And it's very viable from the perspective of either access, latency. If you've got data privacy concerns, you can think about, like, for instance, here in South Africa, we know that we can't put data outside of South Africa that doesn't have commensurate legal protections for data privacy, for personally identifiable information, as what's here in South Africa. So there's a lot of flexibility and choice you get by having all of these different hosting options. Just some stats about what's going on in Azure today. The real one I want to call out there is kind of right in the middle, that 500 million user objects on Azure Active Directory. So we as blockchain practitioners in this room, there's a lot of interesting dialogue and discussion going on about identity and identity management. But we also have to think about things like, from a user experience perspective, single sign-on. We already have a vast array of identity management infrastructure and requirements around corporate credentials, user access, multi-factor authentication, so on and so forth. So it would really delay us and really hamstring us if we had to recreate a whole nother identity management subsystem to do our blockchain applications, because we have our wallet, we have our public-private key pairs, so on and so forth. So why not bring those things together? Why not have a platform that allows you the capability to say, right, I've got my corporate identity here, perhaps I've even got some consumer-facing identities, whether it's my Google account or my Facebook or Microsoft Live, so forth, and I could bring those together, I can aggregate them into a federated directory model that could then also interoperate and interact with whatever keys I have associated with my blockchain transactions and my blockchain persona. So really the idea is, we've spent the last 20 years as IT practitioners thinking through things like single sign-on and directory services. Why reinvent the wheel? Why not just go for an integrated approach where you could harmonize the directory infrastructure and the environment and the investments with what you're going to do in the blockchain? We've also got, besides just the cloud, we have a very interesting capability called ExpressRoute. And the ExpressRoute capability allows you to have essentially a site-to-site VPN connection from your on-prem data center into your cloud subscription environment. So let's say you do have very sensitive workloads that for whatever reason just are not there yet to go to a public cloud environment. That's okay. You can actually have this hybrid scenario where you've got on-prem data, on-prem applications that can actually interoperate using an extremely robust, extremely large fiber network with what's going on in the cloud. So it really gives you architectural flexibility to figure out and to pick and choose which services, which pieces of data and application functionality you want living in the cloud versus on-prem. We've also made a very significant and serious investment in the area of security and compliance. So my own personal story, I actually joined Azure about 3 years ago. I was hired as the risk manager. So Azure made a decision that in order for Microsoft to really gain the trust of the financial services community, the public sector, energy, healthcare, so forth, we really had to build a hyperscale, robust compliance regime. And that regime had to factor in a multitude of global security certifications, standards, audits, and fundamentally at its core, a risk management program that was able to go service by service, Azure building block by building block, and put them through a continuous audit cycle of interrogation, investigation, incident response, penetration testing, and the like. And we had to really choose the standards that resonated with customers. So when we talked to financial services folks, it had to be things like SOC 1, SOC 2, SOC 3, FFIEC, so forth. When we talked to the US government, it had to be things like FedRAMP and DISA and ITAR. When we talked to various countries around the world, each of them expressed an interest with their particular data protection and privacy standard. So we really made a significant investment. I actually come from a team called Azure Global Ecosystem where this is the sole focus. And you're talking about 150 engineers and project managers dedicated full-time, not only just to compliance, not only just to the audit servicing piece, because that in and of itself can get pretty rote, but actually forming relationships and embedding conversations within each individual service team to design in compliance from the ground up, to make sure that they follow a system development lifecycle approach to have compliance requirements formed into their very backlogs of the services that they're building from a continuous and a DevOps perspective. So given that backdrop, so that's the platform. That's like Azure as the environment, and that's what's great about that is it applies to any type of service that you're going to then instantiate and host on Azure. Now let's get a bit more specific to blockchain. So the first, there's two real concepts I want to introduce here. So first is the cloud hosting piece, which again is, you could think of it as like your IaaS, your infrastructure as a service. And it's effectively, you have this environment for virtual machines to then provide infrastructure to host your distributed ledgers on. The second is this idea of the marketplace. And the marketplace, roughly speaking, is our app store. So you come to the Azure marketplace and you say, I've got my Azure subscription, and this is what I'm interested in deploying. And what we're showing here on the right is that we really don't care. I mean, certainly we've done a fair bit of work with Ethereum, but beyond that, we really want to be open to whatever ledger technology you work with or is emerging at the moment. So we really try to take a note to respond to customer demands and say, right, if customers want Hyperledger Fabric on Azure, great, that's what we'll give them. If they want R3 Corda, if they want Chain, for us it doesn't really matter. What really matters is providing that platform to get the customer to the place of rapid experimentation. Let's move past the infrastructure setup and get to what's interesting, which is, will my business model or my application work from a blockchain perspective rather than getting bogged down in all this infrastructure setup? So comparing and contrasting, so we, about a year ago as we started this journey, we did a hackathon internally and we said, okay, what does it take to build out an Ethereum network manually on Azure? And it really took us about 3 weeks. We did this internal hackathon and we tried to get our own consortium network going over a series of variety of nodes and network them together and mine some smart contracts. And it was a very painful process because we had to make sure we got the right build of Ethereum. We had to figure out, oh gosh, are we going to use GoEth? Are we going to use a C++ client? What are we going to use? We had to get all of the prerequisite packages built. We had to manually provision our virtual machines. We had to fight our way through networking to configure the network protocols on the ledger, but also just the network protocols across our various subscriptions. So it was a really manual and cumbersome process, and we hadn't even got to the point yet of doing anything interesting with respect to building an application or developing smart contracts. So using the marketplace approach, so what's fundamental to this is there's a piece of technology we have called ARM, Azure Resource Manager. And what the Azure Resource Manager provides is effectively an automated scripting platform based on JSON where you can say, in my subscription, automatically provision this number of virtual machines, network them like this, use these other application services, and press go, and within like 15, 20 minutes, you actually have that environment set up and ready to run. And so when you use the marketplace perspective, so you come into marketplace, you do a search, you type in blockchain, I find the one I want, you press go, you've got a platform that's actually ready for you to start development and to start implementation on. Here's just a view of the marketplace. So again, you can see the different blockchain offerings there. This is constantly changing. So as we get new requirements and new requests from customers, we actually put those things as ARM templates out into the marketplace so that you can actually start and get started rather quickly. Just real quick, I've got a warning on the PC here that the battery is running low. I don't know if that's... I'm going to go out like Trevor Noah, get the screenshot there. So then just let's actually walk through that experience. What is that experience like? So this would be my subscription. So I'd come in here. I would say, right, I want to actually deploy this Ethereum network. So what you're looking at then is the set of information that you would actually provide. So that first row there, how many consortium members do I want in my sample network? How many nodes per member am I going to actually provision? So in this case here, we're envisioning a network of 7 participants, and those 7 participants are going to have 2 nodes in each. Then I've got some decisions there on the right about the sizing of my virtual machine, so I can make some informed decisions about how much speed and size and scale I want associated with my virtual machines. Then I'm going to actually provide some details about my Ethereum settings. So I fast forward here, I've got the summary of that. I'm able to provide sort of the initial account where the keys are going to live. Now, of course, all of this really rests on you having good administrative controls, because this is being done by whoever has your cloud subscription admin capability. So that person, number one, is going to have access to this cloud subscription where these resources are going to get provisioned. But number two, they're obviously the person providing the information about the root password, the initial Geth account, and so forth. So it's going to be very critical that you have sort of good process to maintain that. Otherwise, obviously, that can get compromised. And at that point, once I press go, here's what I've just provisioned. So I've got a front end. So you've got the user on the far left. They have a web interface to have an administrative experience over their now functional blockchain Ethereum network. That's fronted by a series of software load balancers. So you've got different subnets that are there for each of the participants. So each consortium member gets its own subnet. That subnet has a division of labor between transaction nodes and mining nodes. That's all configurable. All of that information is then stored in an Azure storage account. And then we've got a ring fence of Azure virtual private networking and software-defined firewall rules that, even though this is hosted in the public cloud, we can really restrict and lock down how the communication takes place, what's exposed. And it really sets you up for then API development, where you can then wrap this whole thing in an API that, again, is then controlled by network firewall rules around how you actually transact with that data on the ledger. So then from a development perspective, really what we're talking about here is this journey from, you have the Bitcoin experience 1.0, where you've got effectively straightforward transactional, UTXO input-output exchanges. 2.0, we saw the introduction of smart contract. What we're really proposing here is making it cloud native, again, because we're betting on the fact that these network effects and these network relationships are going to be very complex, and it's going to be very challenging to go to individual IT departments to sort of stitch these together. So make it native for the cloud, make it easy for the cloud. The other thing the cloud brings you is all of these building blocks, like we talked about with identity management, where it becomes much more suitable to actually envision and imagine an enterprise class application. Because that's going to be the toughest sell, is everybody is very excited about the ledger. Everybody is very excited about the decentralization and the replication of the data across the ledger. But you still have to have good fundamentals around enterprise application development. You still need a UX. You still need telemetry. You still need monitoring. You can't get out. Just because we've disrupted doesn't mean we can get away from good standard IT practice, good standard IT security to actually run these things. And so the nice thing is that we already have this componentry, so why not take what works and what's proven and then marry it together with the new and the exciting, the blockchain and the distributed ledger, and have a more robust framework. And then finally, we have this innovation called cryptlets. And so what the cryptlet is kind of a new way to think about doing smart contract development. And we'll get into that here in just a moment. So this is really the stack that we're talking about. So for the time being, we're not really concerned with what type of ledger is out there. So if you want to run Ethereum, as I mentioned, if you want to run Ethereum, Hyperledger, fantastic, great. Do what works for your business and what works for you. That's at that bottom stack. So really, here's the virtual machine. It's an IaaS experience. Provision your ledger through the marketplace, and you're off and running. Where we're trying to focus as an engineering team is on that developer community, that developer experience that then has to take that ledger infrastructure and do something with it, and take one of these use cases and actually put an API around it, actually do identity management, actually do big data and analytics. And those are the pieces, those are the building blocks highlighted in red here that we're really trying to streamline and make easier for our customers to get off and running. So we call it our minimum viable product. So this is a kind of a drill down of what that looks like. Imagine you have a client layer. Doesn't matter whether you're accessing this application through, say, a mobile device, a tablet, a web browser, regardless of the case. You have this then API layer where, again, as we're going to talk about with cryptlets, you've separated out your business logic and an abstraction layer that provides this gateway into then the ledger tech itself. You've got then also hooks into the identity management infrastructure represented here on both the left and the right by the Azure Active Directory. And again, what's really compelling too is if you're already an Office 365 subscriber, you already have access and you already have Azure Active Directory accounts. So it's the same directory service, that underpins Office 365 is what we're talking about plugging into here to hopefully get to that single sign-on experience where it makes credential management much more streamlined and efficient. So then a little bit more about that framework and the cryptlets and this whole notion of kind of how do I think through smart contracts in kind of a next generation way. Well, traditionally smart contracts, what we're looking at here is on the left you have your traditional paper-based contract, right? So we imagine that paper-based contract is comprised of these static properties, things like the tenor of the contract, the signature, what it is that's actually being exchanged or bought and sold. Then you have sort of these dynamic properties, things like maybe there's a variable interest rate associated with the contract. Then you have this idea that there's actually business logic associated with the contract. What happens if it's a loan agreement and I pay early? What happens if I'm delinquent in my payments? Are there different fees that are going to accrue? How do I then incorporate those into the outstanding balance reflected at bottom in the ledger with respect to this overall agreement? And then, of course, being a smart contract, it has to be mined across the blockchain network. Now, as you scale, this becomes somewhat problematic because of the fact that you've got potentially a significant set of business logic and code that then gets mined into this network, that then gets propagated. But then what happens if regulations change, rules change? I got to go back and remine my smart contract, and I got to wait the propagation all over again. Well, meanwhile, if folks are still transacting, you could get some funky things that start to happen, because if you've got transactions coming in and a smart contract being updated, what then? So what we're proposing with this cryptlets framework, and this is what we talk about when we talk about our Project Bletchley architecture, this is fundamentally what's at the center of it, is this notion of separating your business logic from your data. And so if you think about it again, going back to what's really worked over, say, the last 20 years of good e-commerce applications, obviously there's not perfect, there's chances to improve, but we postulate that from a blockchain perspective, if you pull the business logic out, it gives you better versioning, it gives you more flexibility over the types of languages. So for instance, if you're an Ethereum shop, you don't necessarily have to do everything in Solidity now. And you can have the smart contract really focused on your data dictionary, your definition, your asset, and the ledger itself, the data. So really optimize the ledger for what it's good at, which is really keeping the immutable storage, propagating that immutable storage across through other ledgers, and serving as that single source of truth. Then you have your traditional sort of application development experience or metaphor being manifest in this cryptlets package that could then transact and serve as the gateway into that distributed ledger. So what we're talking about is an architecture that we call the Bletchley cryptlet fabric, where as you create these cryptlets, imagine that they're effectively libraries. Right? The metaphor I like to use is think about sign macros for Excel. Right? So if we imagine Excel as our ledger here, now imagine it's networked. Then you have some type of ActiveX control or a macro that actually has to be signed before it'll actually work. That's what we're talking about here with the cryptlet. So a couple of advantages here that are going on simultaneously. One is I'm actually registering that cryptlet in a service in my cloud subscription called the Cryptlet Fabric. So every cryptlet that's going to make a call against blockchain ledger data is going to be registered and is going to get its own signature in that fabric. Second, I'm then going to also register my blockchains. So in the example here, we've got 3 different blockchains that are involved. We've got somebody running a Corda, somebody running an Ethereum, somebody running a chain. So by registering those blockchains with the fabric now serves like as an enterprise service bus that's able to use policy to say, right, I know I've got these cryptlets talking to these ledgers. So it becomes very interesting because if you entered into an arrangement where different consortium members are running different ledgers, you now have that cryptlet capability to send data across to each of those ledgers. The other thing that the cryptlet gives you, and really hence the name, right, is this secure enclave environment. So we're currently testing out with trusted execution environments, TPM style hardware encryption, where we have these secure enclaves that can run the cryptlet. Because the thing we're definitely sensitive to is multi-tenancy in the cloud, right? A lot of security practitioners, and rightfully so, have very serious and grave concerns over multi-tenancy. And so you do want to have a trusted, dedicated, encrypted application space to run these criplets in, and so that's what you get with this setup. So revisiting our architecture. So we talked about the hosting needs. So from a hosting perspective, the Azure platform, or really any sort of hyperscale cloud platform for that matter, gives you scalability, it gives you global network functionality. You have, through the compliance regimes we talked about, a higher degree of assurance around data protection and privacy. The ledger infrastructure becomes something that has a lower total cost of ownership possibility because of the fact that you're quickly provisioning these things using marketplace technology, ARM technology. And then finally, the smart contract piece allows you to really focus on the development environment and languages that you're comfortable with, transacting across multiple environments, multiple ledgers. And so what this really sets up is the stage for sort of our next evolution in this is working to have different subscriptions, different ledgers form consortium networks to really emphasize and to really accelerate that kind of decentralized experience where everybody can kind of bring their own subscription to the table. They could provision their own initial blockchain network setup, and those things can just work across the virtual networks that they set up. So again, the biggest thing here, and we talked about as we started on kind of that nimbleness with Microsoft, right? So here you can be nimble by basically just you sign up for even a free trial Azure subscription, and you can search these up straight away. You can go into the marketplace today. I really encourage you to just experiment, do a search on blockchain, whether it's Chain, Ethereum, Corda, doesn't matter, provision it, roll up your sleeves, start to play with it, and we very much, and we really, really humbly want your feedback. We want to know, what isn't there, what's missing, what's too hard about the setup, because we're constantly trying to improve it, we're constantly trying to iterate and release new features, new functions, because we really want the experience, we really want to encourage innovation, and we really want people to try this out. And again, the great thing about the cloud is if you get it wrong, you throw it in the bin and you start from scratch and you reprovision. And that's not a costly endeavor. It's not like you're out all of this time from all the hardware you provisioned and all the connectivity and so forth. We've also got a variety and a wealth of white papers and materials. Basically, the key takeaway here, if you go to www.microsoft.com/blockchain, you'll find a lot of these links. And you can read the white papers in depth about the criplets. You can read much more detail about the architectural framework, what's coming next. There's some very compelling blog posts that are out there that give you a flavor and a taste. But really, the takeaway here is just to try it out. Let us know what you like. Let us know what isn't working. And we're really trying to listen to your feedback and to your concerns. Thank you.
Michael, thank you very much. We're going to take a few questions. We've still got a few minutes. Any questions for Michael? Yep. Thanks, Adrian.
The cryptlet idea, I think, is very cool. How easy is it to deploy cryptlets that are using public blockchains, though? Is it exclusively for private instantiations of blockchain tech, or can you deploy a cryptlet where the backing data is actually a public blockchain?
Great question. So let's talk about that in depth, because right now it's very hard. It's very challenging, and it takes us as engineers a lot of setup, because the first thing you have to do is you actually do have to mine a smart contract that is what's called a crypto delegate that serves as the bridge between the cryptlet fabric and the specific blockchain. So what that really means is primarily it's focused on a private blockchain. Because, I don't think Ethereum is going to say, hey, here's our public Ethereum, have at it. So I don't know what that would look like. I really don't know what a cryptlet against a public blockchain would actually look like. But from a private perspective, again, you really have this idea that you have this crypto delegate, which, like, if you think back in the days of like an ISAPI web filter for like IIS, it's basically the same thing. It's that hook between the fabric and the actual ledger to provide the communication.
Great, thanks. Any more questions? Thanks, Monica.
Hello?
Yeah.
Hello? Would it facilitate interoperability?
I'm sorry?
Would it facilitate interoperability?
Yes. That's really a key driver, interoperability for us, due to the fact that, number one, if you've got this fabric with different blockchains registered, you can think of the fabric as providing this adjudication service. So the fabric provides kind of translation and connectivity. So again, the key fundamental there is as long as you have the delegate piece for each blockchain you're talking to, That's really the gating factor. Now, that's obviously a big gating factor because there's so many different ledger types. You know, what's the likelihood that you're going to have a ledger that maybe we don't have a delegate yet with? And obviously, that's pretty high. That said, we feel that the framework is extensible enough that it's certainly within the realm of possibility to partner with a customer and say, let's say, for instance, I've got, I need a multi-chain and I need a chain, interoperating together. Great, here we have the pattern for the chain. Let's work together. Let's figure out the delegate we would need to interoperate with the multi-chain and then make sure. So again, while it's still very raw and very rough at the moment, and it frequently requires us to have kind of almost a services type of engagement or bring engineering resources to help you out, nonetheless, it's at least possible and the framework exists, and we can certainly get to interoperability from that perspective.
Great, thanks. Any more questions? Yep, right at the back.
Okay, this is a very good project, and I think the financial services, the mainstream financial players, they are already comfortable with Microsoft, they are comfortable with IBM, they are comfortable with most of these tech giants. So my question is, I think this is going to help adoption. And what in your roadmap do you have to, do you have these players, these mainstream banks as your target customers? Are you working towards developing some of their existing services in the cloud like this?
Great question. Yes, we are certainly focused on very large mainstream players. So we recently had an announcement, 28 February, of the Enterprise Ethereum Alliance. And that announcement was done in conjunction with, Santander, JP Morgan Chase, so some very large players. That said, we don't want to limit ourselves. So while those are certainly wonderful customers and they provide excellent use cases and requirements for us to really prove the technology out, you could really think of it as kind of these three tiers of customers, right? So one is kind of your classic enterprise, which that fits into the mold. One is ourself. As I mentioned, Treasury is probably arguably my most important customer, my most important interaction, because I really owe it to Microsoft shareholders and my fellow Microsoft employees to be as efficient and as innovative as possible. But then the third is really kind of the startup community. And I must confess that this is where we traditionally have sort of a bad track record, and we ourselves aren't very good and very nimble historically with kind of the startup community to get them to think Microsoft. I think Microsoft still has a legacy of, oh, that's kind of closed infrastructure, or that's not cool, or whatever the case is. We would definitely like to start to get more mind share and more folks using this environment as a rapid prototype, rapid development type of environment and experience. So really trying to move those products, those designs like Cryptlets across those three tiers simultaneously, the classic enterprise, Microsoft internal, and the startup community is really, really big. And then I would say within the enterprise space, obviously financial services is key, but there's also the other industries I mentioned in the use case discussion as well.
Great. Thank you very much, Mark. Good one. Thank you. Thanks for coming to South Africa.
Absolutely.
Thanks
My
for
pleasure.
making the trip. Good. Right. Next up, we have Francisco Corza from Berman Gilfillan, and we're going to talk a little bit about cryptocurrency, central banking, and regulation. So that's a theme we're going to continue from yesterday. Welcome.